So my name is Dillon Kearns. I'm an Elm coach and trainer, founder of Incremental Elm Consulting. And so check us out at incrementalelm.com. And today we're going to be talking about Elm GraphQL and kind of digging into some of the fundamental skills and concepts to demystify some of the basics of GraphQL and Elm GraphQL. So before we dive in, first of all, I'm curious to get a sense of the room and who's here. Who has used GraphQL at all, ever, even playing around with it? Okay, and who feels pretty confident about like the basic concepts of GraphQL? Okay, some people don't, some people do. So regardless, we're going to be kind of going over the basic concepts. So if you're not familiar with them, that's okay. I'm going to be covering them because I think that understanding some of the basic concepts of GraphQL really deeply will allow you to understand and work with Elm GraphQL more effectively. What about Elm? Who's used Elm in any way, shape, or form? Cool. Who feels pretty experienced and comfortable with Elm? Okay, cool. About half of the people in this room. Cool. So let's just take a minute and just talk to somebody sitting close to you and describe what success would look like out of the next hour and a half, 2 hours. What would the visible outcome be after having gone through this session? Sure. All right. It's somewhat quieting down, so can I just get like a couple of highlights of conversations? Just shout out something that came up that would be a successful outcome for this workshop. Yeah?
I like safety because I'm getting old and life's too short to not have it.
Love it. Love it.
Trying to convince coworkers to use Elm.
Oh, nice. Great. Yeah?
We're starting to use PureScript at work, and we have a big GraphQL backend, and I have a hard time finding a good GraphQL client in PureScript, so I'd like to see how this is done, and maybe steal it.
Maybe a little inspiration. By all means, yeah. I'm all for it. I think there are some really unique features in Elm GraphQL. I'm happy to chat with you in more detail after of some of the things that make it unique. I think there are several features in Elm GraphQL that no other GraphQL clients, even in typed functional languages, have. Which, please feel free to steal them. Yeah. Awesome. Okay. So great. So I'm gonna give a GraphQL intro. And again, even if you're comfortable with GraphQL, I hope that like revisiting some of these concepts will make it easier to deal with the Elm GraphQL library. So, first of all, GraphQL was created by Facebook, and so you can kind of see in some of the design decisions that it makes sense that it came out of Facebook because it's solving some of these problems of, traversing these huge graphs of data. So who's using it? There's rapid adoption. It seems to be growing almost exponentially. GitHub's latest API is in GraphQL. The New York Times, of course, Facebook, Atlassian, the list goes on and on. Airbnb is heavily investing in it. A lot of major companies are using GraphQL very seriously. Sorry. I I had a page up and forgot that I had split screens. But yeah, Shopify is heavily invested. There are a lot of large companies that are using GraphQL quite seriously. And it's well suited for even environments that require really high performance. So it's a perfect fit for Elm, as we'll see, for a lot of different reasons. Largely because it's a typed schema for your API, and Elm is a typed functional programming language, so they fit really nicely together. There are a lot of benefits of GraphQL, and that could be the topic of a whole talk or set of talks. But one of the headlines is that it can really help you avoid these problems of underfetching and overfetching. So if you have your Internet of Things devices that are trying to hit it, and you have your desktop and mobile and native and all these different clients that have different needs, different kind of payload sizes that that you want for performance reasons, it becomes pretty unsustainable to just have every permutation of every API endpoint for each of those different devices. And then, of course, you have to do the sort of REST dance to get, give me the users, and then you get a bunch of IDs for the user's friends or whatever relation you want to traverse, and then you make a bunch of requests if you want more details on that. Or you tack on a little query parameter that magically tells you to do these things, and it's all very ad hoc. So GraphQL not only solves those problems, but it gives you kind of a very sane way of expressing those things that doesn't feel quite as ad hoc. Plus, it's built from the ground up with tooling in mind. So you get these really neat tools like Graphical, it's pronounced Graphical, which is the GraphQL live query editor and runner. You just open up your browser window, and instead of navigating through some really poorly documented REST API, you can pull up the documentation right there, and even if you haven't added annotations to put docs specifically, which is very easy to do, and it'll just put them in line if you did. But regardless, it'll tell you the types of things and how things relate together and how you can traverse to get different bits of data. And it'll actually give you underlines and tell you if you're trying to get types of data that don't exist or misspell things or don't pass in a required argument, things like that. And it's built with introspection in mind, so it's a very effective tool for building tooling. It's a sort of nice platform for building a lot of tooling, such as Elm GraphQL. Elm GraphQL leverages the introspection. So if you have a GraphQL API, you can query any GraphQL API, whether or not the person maintaining that API knows it, and you can ask it to introspect itself and tell you what are the fields you have, what are the types of those fields, what are all the relationships. And that's what Elm GraphQL does. It runs that introspection query, it figures out what the API does, and it generates code so you can make type-safe queries from Elm. So I mentioned documentation navigation. Pretty cool stuff. Just at a really high level, some challenges. It solves a lot of problems, and it introduces a few new challenges. So caching can be challenging because we have a lot of tooling around doing caching that assumes that you're only going to cache GET requests, for example, and often GraphQL is making POST requests, and you have now these flexible payloads, and how do you manage caching that? So servers are kind of catching up to a lot of these new practices. It's not that they're unsolvable, it's just that people are still figuring out best practices and tooling around some of these new challenges. Also, while GraphQL can kind of avoid n+1 queries on the front end side where you don't have to get users, and then for each of the user's friends you have to make a request for the details of that friend, you can pull the n+1 queries to the server side. So the way that GraphQL kind of composes together these resolvers where you say, this is how you get this piece of data, and this is how you go from this piece of data to this piece of data. You can introduce n+1 queries in the SQL query execution side, where it grabs these things, it says, okay, I need to get friends, and then for each of those I need to do this, and then it executes another SQL query. Whereas you can just optimize a REST endpoint and say, here's this highly optimized query. So it solves the problem, makes the problem harder in other ways. Okay, so that's what I'll say about GraphQL at a very high level. So some of the concepts, let's dig in a little bit to the schema definition language of GraphQL. So the schema definition language is just, it's just a way of expressing types in GraphQL. So, GraphQL is a sort of language for expressing the types of your API. So here's an example of the schema definition language for defining a very, very simple GraphQL API. So in this case, when it says query, we're saying query is just the top level things you can query. This is like the equivalent of, these are all of my REST endpoints. It so happens that in GraphQL, there's only a single endpoint rather than many different queries, and you can just grab any piece that you want, or multiple pieces, from the top level query. But in this case, our schema, sorry, that green's a little hard to read on this projector. Are people having trouble? I'm not really sure what to do about that. It's okay? Okay. Okay, so in this case, the only thing we can query in our entire API is hello, is anyone home? And so let's take a look and play around in a, let me mirror my displays here. Okay, so we've got hello, is anyone home? And if I, you'll notice that it's offering this auto-completion. Actually, it's pretty neat. If I command click into it, it's even telling me the type is string. So if I try executing this, hello, is anyone home? Coming, oh, it's null. One sec, I'll be right there. Okay, so sometimes it's null. So I guess if it's a string, it's nullable. So that's kind of too bad. But it turns out that that GraphQL actually allows you to express nullability. You can mark a field as nullable or non-nullable. But if you don't put anything there, it's nullable. If you put an exclamation point after, it's non-nullable. So this is the data we're getting back from the server, and you'll notice that the shape of the request, it looks a little bit like JSON, but without, instead of being key value pairs, it's just kind of the JSON keys, right? So it looks kind of like this JSON-y thing, and then hello, is anyone home? And then we get back this thing, and instead of just the key, hello, is anyone home? It's a key and the value. And that's just kind of how GraphQL works. The shape of the data that comes back matches the shape of the data that you request. Okay, so a field in GraphQL is just any bit of data that you request in your query. So if we look at hello, is anyone home? That's a field that we requested. Okay, so nullability. So this is what a non-nullable field looks like. It's got an exclamation point after. Okay, so you might be wondering, how does it know it's non-nullable? So if I, so in our API here, we've got hello, which is a non-nullable string. String bang means non-nullable string. So if I query for hello, I should get back a non-nullable string, right? Like, oh, okay, sometimes I get a string, and sometimes I get, like, what's all this garbage here? Well, so the way that GraphQL works, it's composed of these resolvers. So GraphQL, whereas with a REST API, you might have some special helper functions in your Rails controller or whatever framework you're using that kind of check certain conditions and make sure that the right data is coming in and the right data is coming out. With GraphQL, you have an API schema that describes everything, all of the arguments, all of the things you can request, all the data types. And the GraphQL framework you use, whatever framework, it could be a number of different languages that you're running for your different frameworks. Actually, you can even have frameworks that are database driven, that are just looking at a Postgres schema and generating your GraphQL API. But whatever framework you're using, GraphQL is just a spec. It's a language agnostic spec. And if you're using a GraphQL framework of any kind, then that GraphQL framework is responsible for giving you these messages. So you will either get back the type of data that your schema says it has, or you will get back an error, and that's guaranteed by the GraphQL spec. So in this case, we're getting back these errors, cannot return null for non-nullable field. It would be nice if it was fully type safe. But in this case, all of the examples are running on JavaScript, so they're not type safe at all. But there are ways to build type safe GraphQL servers as well. Rust has you can do end-to-end type safe applications. There are people building Haskell GraphQL servers as well. If we look at our server real quick, hello, is anyone home? You can see that I have this maybe respond function. This is the resolver that I'm using to define hello, is anyone home. So it will randomly return null or some string, right? And I'm using this maybe respond thing to return a non-nullable field, right? So if I were to change this to just return a hard-coded string and rerun this query, and it's not happy because I forgot the syntax of this. Need to do a lambda. Rerun this, and I won't get any errors anymore. Okay, so that's kind of how resolvers work, and that's kind of the role of the GraphQL framework versus the handwritten resolvers that you as a user define. Okay. So, so these are GraphQL fields. Again, GraphQL fields are just any bit of data that you can ask for is a GraphQL field. So there's also something in the GraphQL type system called a scalar. And what is a scalar? Well, scalars are just the leaves in your GraphQL schema. So for example, there are some built-in scalars. A string is a sort of terminal value. It's one of the leaf values that you can have in your application. Integers, floats, booleans. There's actually an ID type, which can have an underlying type of a string or an integer. And then you can define your own custom scalars, which are just kind of little wrappers that give a name to one of those other primitives. And then there's also an enum, which is pretty cool. So you can have enums. For example, you can have an enum defining order, which is either ascending or descending, which is pretty nifty because then you can get some cool guarantees. And if you run your Elm GraphQL code generator, you'll actually end up with a union type that it defines for you, an Elm custom type that's either ascending or descending and can never be anything else. And your compiler is aware of that, which is pretty cool. You can find objects, which is just collecting together other scalars, these primitives, or other objects. So it's a collection of fields. So in this case, a package, like if we're browsing an API that lists out different Elm packages, different Elm libraries, then it could have a title, a URL, and a list of versions. And again, the title is non-nullable here. So now the graph part of GraphQL, so that's all kind of the query language part of GraphQL. How do we define the different types of data and what data you can query for? But then you can traverse these relationships, right? So that's the graph part of GraphQL. So we're going to be working a little bit with an API that I defined, which is actually just a very simple wrapper around a REST API. that turns it into, it's just a very simple kind of adapter in front of a REST API. So you can query for favorite packages, which is going to give you a list of these package objects. So if you query for packages, a package is an object, so you can request data from the object. So you can ask for the title or the URL of a package. So this would be an example of a query where I'm saying, I'd like to get my favorite packages, and for each of those packages, please give me the title. So that's how you query for data from an object. Package is a type of object in the GraphQL schema, and we have to tell it what data we want from that object, or from each of those objects, since favorite packages gives us back a list, not a single object. And note, anytime we see the curly braces, that's called a selection set in GraphQL terminology. So remember that term. A selection set is just saying, from this object, these are the fields that I want. And it's recursively defined. So actually, even at the top level query is a selection set. Here is the set of things I would like to get from the top level. And then, well, it's a set of one thing. I would like favorite packages. And here are the things I would like for each of those package objects. Selection set for favorite packages is give me title. And it ends there. So if title were an object, I would have to pass it a selection set to tell which fields I want from it. But since it's a scalar, it's just a string, not an object, you don't pass it a selection set. Okay, so selection set is a very core concept to the Elm GraphQL API. It will save you a lot of confusion if you just remember this one very simple idea. If you see curly braces, that's a selection set. Anywhere you see those curly braces, it's opening up a new selection set. Okay. So yeah, so you have to explicitly state the selection for the sort of branches, the objects, and then the scalars are sort of the leaves, so you don't have to express a selection for those. Okay, so you can, again, it's GraphQL, so we're traversing these graph relationships. So actually our API not only has favorite packages, which lets us reach in and get these packages, but from a package object, a package actually has a relationship to an author. So we can ask for data from the author. So we can kind of go from give me the favorite packages and give me the title of that package. But then we can also say, well, I don't only want the title of that package, I also want the author, and give me that author's name. We could ask for other fields there as well. Do you have a question?
Is this in the context of a relational database?
Great question. Is this in the context of a relational database? It's completely agnostic. GraphQL is actually a really lightweight layer that sits above the persistence layer. So it's completely database agnostic. It doesn't care. Actually, this API that you're going to be playing with in a minute is backed by a REST API. And it's actually a completely flat REST API, which just dumps a bunch of data. And I created the relationships by just creating a couple of functions that figure out how to traverse that. But it could also be a relational database. It could be it.
Like if you're communicating directly with Postgres and say there's
Yeah.
a one-to-many relationship between, I don't know, packages and author,
Yes.
it would be able to figure that out.
Right. So if you're communicating with Postgres and you want to go from packages to author and there's like a foreign key connecting them, yeah, you would actually tell it how to do that. Okay. You would tell it in a resolver. So that's you piece together these resolvers. So it's completely agnostic, much like if you define, in many frameworks you define a REST endpoint and you just figure out how to grab the data. In GraphQL, you tell it how to grab each piece or traverse each relationship, and then it kind of composes those what are called resolvers together. So you tell it, given an author, how do I get a name? You tell it, given a package, how do I get the author? You tell it, given, how do I get and it pieces those together based on the incoming query. Yeah, great question. Okay. Cool. And we could even loop back, right? So you can kind of have these circular loops where you can get an author, but you can also ask, well, okay, here are my favorite packages, but what other packages has this author created? So you can define all of these relationships any way you like. Okay, so again, all of these things are fields. So these simple scalars, hello, is anyone home, returns back a maybe string. That's a type of field. It's a scalar. Hello returns back a non-nullable string. That's a type of field. And favorite packages is also, it's just a field. Favorite packages is a field. It happens to be a field that's not of a scalar type. It is of an object type. It's actually a list of objects. Package is an object. And so again, when we get that favorite packages field, we have to give it a selection that says, what do you want for each of those objects? Okay, and then GraphQL also defines mutations. Mutations, oh yeah, please.
Just so you know, you don't have to answer it, but
yeah.
hello queries are not working for only a package.
Oh,
The package code again?
that's a different API. Yeah. Yes.
Okay.
Yeah. Sorry, what was your question?
Can you just show the package code again?
The package code.
It used to be easier.
This, okay, cool. Cool.
If you want to use the hello queries, you can change that server file.
Yeah.
It points at Elm stuff right now.
Yeah, that's right. But we'll be playing around with the pink circle API in just 1 minute. Yeah, cool. So we're about to get into the exercises. Okay, so cool. Thank you for the questions. Okay, last thing I'll say about this, mutations. In GraphQL, mutations are nothing more than a way to, it's a convention that you say, if I'm going to be deleting something or updating something or launching nuclear weapons or whatever, then I'm just going to define it in my mutations, right? But it's nothing more than a convention. So we're going to be starting by dealing with queries. But again, they're just objects as far as GraphQL is concerned. It's all just selection sets, fields, objects. It's all these basic pieces. So if you understand those, there's actually nothing more to understand about mutations other than it's just a convention that you define queries at the top level, which is a bunch of, these are the fields that you can get at the top level. You can define mutations, which is just a bunch of fields that you can get that by convention are perform some sort of side effect. And there are also subscriptions, which we won't be getting into, but those are the 3 top level things you can have. Okay, so now we're going to be playing around with, this exercise, don't worry about the Elm code. We'll get through this one pretty quickly, but this is just to get your hands a little bit dirty with some of these GraphQL things yourself, just to make sure that you're on board here. So go ahead and just do run.sh source/part00. And again, no need to touch any Elm code at all. Just go to the window that your browser opens. And actually, let me run it here. So run.sh source part00. And then localhost 8000. So it's got, it's got a few questions here. So just walk through this. You don't need to open up your editor or anything. So, and just to give an introduction to what this is what we're going to be working with for all of the exercises. So the pane on the left, This is just the standard. It's called graphical, GRAPHIQL. And this is just a little query explorer for constructing and executing GraphQL queries. You know, if you do control space, it'll give you auto-completion. It'll tell you if you build up an invalid query because it's aware of your actual schema, and it will enforce that you're building up a correct query. And then when you execute it, you'll get back the data in the middle pane. And then the rightmost pane, we're not going to touch or really pay attention to in exercise 00, but we will in exercise 01. But that is data that's coming back from Elm. So that's it. I'll just give a couple of minutes for us to run through. Just go ahead and read this. And feel free to pair up and discuss if you like to work that way or do it solo. I'll walk around and answer questions. So let's jump back into it. Oh, is my voice suddenly projected? OK, so with all of these exercises, first of all, I'll be walking around for questions and more than happy to help with whatever I can help with. And secondly, if you don't get every single piece of the exercise, that's OK, because I'll just quickly run through the solutions before we move on to the next one. So, you know, get what you can. Don't feel too rushed. If you don't get everything, that's perfectly fine. OK, so understanding GraphQL. So yeah, graphical is a pretty nifty tool. You can navigate around. You can kind of command click on things and see what the types are. You can look through the docs. You can see the entire schema. You can kind of click through and see all these types. And this is not a custom built thing, right? If you have a GraphQL API, this comes for free. OK, so let's get the title for each of my favorite packages. So let's just, if we go to favorite packages, we'll see this is a non-scalar, right? Package is an object that has a set of fields. So favorite packages. So since it's not a scalar, since it's an object, we need to pass it a selection set. A selection set is just a thing in between these curly braces. So for each of the favorite packages, we want to get a title. So here are some favorite packages. OK, so that's the QL part of GraphQL. It's a query language, but it also gives you a way to kind of describe and traverse these relationships. That's the graph part of GraphQL. So for the graph part of GraphQL, let's get the name for each author in this query. OK, so if we look at authors, if we look at authors for author for a package, so author is, the type is an object. If we look at the definition, we can get a name or the packages by that author. And we're asked to get the name. Let's put in the name there. And if I execute that, then I've got, for each of these favorite packages, I've got a package title, and I've got the author's name. And again, notice that the shape of the request matches the shape of the data that comes back. OK. Now, for each author in favorite packages, let's get all of the packages that author has written. So here we're kind of traversing this relationship where we got the favorite packages, we got the title for each of those packages, we got the author, and we got the author's name. So we've got all this, we've gotten down here. Now we want to loop back and get the packages and the title of each of those packages for those authors. OK, so now we just go into author. I guess I'll just do it underneath to stay consistent. We ask for packages. We're just continuing down this line of relationships. And for each package, I just want to get the title. And now we can see, and maybe I'll just comment out the title there since that might be duplicate data now. So for each of my favorite packages, I'm getting the author. So here's Matt Griffith. Here's the list of packages that he's written. Elm Markup, super cool library if you haven't seen it. Elm Style Animation, Elm UI. Definitely check those out. So that's the exercise. Were there any questions on any of that? Pretty clear? Yeah? Cool. Okay. Cool. So now, for the fun part, we get to dive into Elm GraphQL. So we haven't touched Elm at all yet, and we're about to. First, let me give a little high-level introduction to the concept. When we're working in a language that kind of has this avoidable uncertainty, we're kind of working like, in a language that's not typed. Maybe we're working with JavaScript. Maybe we're working with a JSON API, and we're crossing our fingers, right? Like I hesitate to say we're ever in a state where it like fully works. We're like, I'm pretty sure it works. It seems to be good, and then like we run it to confirm. Maybe we make a change, we run it, we get some errors. They're runtime errors, and then we go through this loop of fix, run it again, not compile it, but run it, get the runtime errors, fix them, and then when we're all done with that and we don't run into any more runtime errors, we're like, okay, I think there won't be any errors now. But we're really crossing our fingers, right? So we like to operate in these environments where we're operating with certainty. When it compiles, we're really confident that like things are working, and we're not going to run our code and run into something unexpected that's not working. So it works, we make a change, we compile it, we get an error and fix it, and we go through that loop, right? That's what we want. But when we're working in this sandbox of a typed environment, Haskell, Elm, Rust, whatever it might be, then we feel like this. But what about when we bridge the gap to another system? Even if it's a well-typed system, like GraphQL gives you a type system for your API. So the kind of goal of Elm GraphQL is to bridge that gap and to take the type system from GraphQL and bring it in so Elm is aware of the types on your server. So now, you, instead of working with Elm by itself, and then you work with Elm where you're hitting a REST API and it feels like this again, you can get back to feeling like this. You make a GraphQL request from Elm, and if it compiles, you're like, yeah, everything is lining up and the types are working out. So I talk in a little more depth at Elm Conf last year. I talked about this in a talk called Types Without Borders. It's on YouTube. Check it out if that sounds interesting. There are some different approaches you could take with a GraphQL client in a typed language. Some tools kind of don't do any code generation. If you don't do any sort of code generation or any macros or anything fancy, then it's not looking at the GraphQL schema. So it doesn't bridge that gap between type systems. So it's just, you have no idea. You're creating valid GraphQL queries, but they might not be valid for your GraphQL schema. To me, what's the point, right? You can also have libraries that kind of generate code. You take one specific GraphQL query, like the one we just built up to get the favorite packages in the title, and then you pop that into a little tool, generate the code for that specific query. That's not what Elm GraphQL does either. What Elm GraphQL does is it generates code for your entire schema. I think of it as it builds a hard-coded library for your GraphQL API. And so you can piece together the little functions and values that are generated for you in that hard-coded library, and you know that anything that you build up, if it compiles, is a valid request for your GraphQL API. And the Elm compiler will tell you if it's not. Thank you. So, so Elm GraphQL, it's sort of a high level, it's like a query building syntax. And the goal is to use Elm language constructs instead of just piecing together strings which aren't well typed, and also instead of using a bunch of like GraphQL concepts, it tries to just leverage the Elm language as much as possible so the Elm compiler can help you. It's just JSON under the hood, but it builds up these things that give you well-typed. Elm uses JSON decoders to take untyped JSON and then make sure that you get it into well-typed data. And it manages all of that for you under the hood. So you just tell it what data you want, and it takes care of making sure that they're the right types. Also, and I think this is unique in Elm GraphQL. I haven't seen any other libraries that do this. You can, above the hood, you can build whatever meaningful data structures you want. So if you have like a bunch of strings and you want to piece it together into your union type, or what Elm calls custom types, you can define any custom type you want. You can have opaque types. You can use any sort of advanced data modeling techniques, and actually, instead of kind of just grabbing some JSON data that's like well typed, and then you take that data and you marshal it into your data structures that you've defined, it's actually just one step. You just define these transformations, and it pops it right into that, so it's never in an intermediary state. Okay, so, and the Elm compiler will tell you if you ever build an invalid query, and you get documentation in your editor. So the Elm GraphQL command line interface, you just run it, and it executes the introspection query to figure out the type of your schema. Point it at your schema. I usually like to check in the generated code. Some people prefer not to. And I usually recommend that you organize the code into a little gen folder. You can create a different source directory in your Elm application. Okay, so I also recommend taking the shortest path to compile. It just makes it a lot easier. Often oh yeah?
Do most GraphQL providers do versioning pretty well, and you use libraries like check conversion and at runtime blow up?
Yeah.
And come out of date?
Excellent question. I had a similar question over here. Yeah, this is a really cool topic. So in a nutshell, many GraphQL shops, like including Facebook, are very hardcore about non-breaking schema changes, always having backwards compatible changes. I actually feel like when you're operating in a type-safe ecosystem, it gives you more flexibility to take different strategies. So with Elm GraphQL, what I recommend is setting up a little continuous integration server script that anytime you change your GraphQL server and it changes your schema, it regenerates your Elm GraphQL code, it recompiles your Elm code, and you can see if anything that your current Elm code is depending on would no longer work, then the compiler will tell you, and then your schema change doesn't go live. And you can even, you could do some tricks like sending up periodic requests to the server to check if the git SHA matches between the client version and the server version, so that you don't have to be backwards compatible for all time. You can also mark fields as deprecated as like a core feature of GraphQL that's built in. It'll show up in the docs with a deprecation reason. So there are all sorts of ways to manage it, but to me, when I know I have type-safe tools, it gives me a lot more confidence to kind of use the strategy that works best for me.
So you say it doesn't work versus having to even worry about it.
Exactly, and there are also tools out there for kind of looking at just overusage, like when was the last time this query was ever fetched? I know that a company, Apollo, which does a lot of like JavaScript tooling for this stuff, so maybe not too exciting to this group, but they're pushing forward a lot of sort of spec changes and tooling in the community. So there's some cool stuff coming out of them, out of their company. And they've got some tooling around sort of like seeing when this was last queried to see if it's sort of effectively a dead field. Yeah?
Is one of the implications of this that you have to kind of wait until the backend team has finished a feature or the servers at least push the schema or like expose the schema before you can start writing your...
Yeah, that's a really interesting question. I know a lot of companies will, that's a whole can of worms that I'm happy to talk about like in lots of depth. But yeah, so one thing you can do is you could kind of design a contract and say, this is what I want in the schema, and then sort of have mocked data and say, okay, we can take that and run with it, and then we'll figure out how to get that data asynchronously. That's one of the techniques you can use. There are all sorts of ways you could approach that, but. Yeah, just returning hard-coded data.
Oh, sure.
Like I was doing with that hello example, just like return a string, just, you know.
Oh, okay.
That would require backend engineers to define a contract.
I mean, well, I don't even want to get into it because I have a lot to say about that topic, but I would love to chat about it after. Okay, so shortest path to compile. We all want to end up with clean code that works, but you can start with making sure the code is clean and then get it working, or you can start by getting it working and then get it clean. And with typed languages, this is even more of a powerful technique than it otherwise would be. So now what about when you have a compiled language? Well, you want clean code that works and compiles. So instead of, I recommend start with just getting something compiling as soon as possible, and then get it doing the thing you want it to. But work in these kind of short cycles of getting something compiling and then going on to the next thing, get it compiling, go on to the next thing, refactor as you go along. So, okay, now we're going to dive into some Elm code. So again, this little window on the right here, this is the data that Elm is returning. So as you edit the code, as you go into this file, source/part1/main.elm, when you edit your query in that Elm file, you will see the data updating in this right-hand column. That's the data that's coming back from Elm, which is different from the raw data that comes back when you perform queries in the raw GraphQL. So I'll walk around and answer questions.
Wait, can you repeat that part?
Yes. The right-hand pane here, the right-hand pane here represents the data that's coming back from Elm. This is Elm data. The middle pane represents data that's coming back from GraphQL. This is raw JSON from GraphQL. So that's what those things represent. All right. So let's run through exercise 2. And again, if you didn't complete the exercise, that's totally fine. We're going to run through it and then get your questions answered. So, okay. Okay. So we want to build up using tiny incremental steps, right? So if this is one of the things that I find, when I get questions about Elm GraphQL, often people will post these like big ugly error messages and say, "What am I doing wrong?" And I'll say like, "Well, you think that you want help with this, but I'm actually going to teach you how to take smaller steps, and then you won't have this problem. You won't end up with this crazy error message that you can't understand." So if you break it down into more manageable pieces, then you can kind of check in at each step and say, okay, this is compiling, things line up, now I can kind of move this around. So what we want to do, so again, we kind of had, in exercise 1, we were querying just a scalar. And a scalar is just something that, it's just a thing in itself. It doesn't need you to tell which bits of data you want from a sort of composite type. It's just a raw type, right? So when we got random quote, that's just a selection set. When we say query.random quote, that is a selection set in itself. Now, if we are not querying for a scalar, but if we query for an object, like favorite packages, then what do we need to pass in to make it compile?
Selection set.
We need to pass in a selection set. Exactly right. So what does that mean? So we're supposed to replace random quote. So let's go to our code. If we open up our query, our starting point has random quote. So instead of random quote, which is a scalar, we're going to get a composite object. So instead of query.random quote, we're going to do query.allPackages. And if we look at the type signature, it's a little hard to read because I got my font bumped up so much. but we can just navigate in here and take a look. So the type annotation for all packages here, unlike random quote is just a selection set, right? But this is not a selection set. Because it's a composite type, all packages needs us to pass in a nested selection set, right? So if we go to our query editor, the equivalent, right, would be instead of random quote, which needs no selection set, we do favorite packages. And then it complains because I'm not giving it curly braces. I'm not giving it a selection set. I need to give it something to select for that for those packages. So similarly, in Elm GraphQL needs us to pass an argument, and that argument is a selection set, the nested selection set, right? So if we want to pass in a nested selection set, let's say we want to grab the title of each of those packages, then we just need to supply that argument. So actually, here's a trick in Elm GraphQL. The way the code is generated, you can just whatever it says here, remember this, the selection context, this is the context that we're querying in. So, so this gives us back, we need to pass it a selection set of things for a package, right? So we can grab this, and we can grab the fields from this module, elmstuff.object.package. But let's take the smallest step we can. So the smallest step we can just say selection set.empty. Now if we say selection set.empty, it's complaining that the type is actually list of unit. So cool. So that got it compiling, right? So now if we look at what's actually happening in the query editor, we get back a whole bunch of nothing. And here's the query that's actually being executed. If we execute it, then sure enough, we get the same thing over and over and over, which Elm throws away and just gives us unit types. But we don't want a whole bunch of nothing. We want a whole bunch of something. So let's do that. So so again, we need a selection in the context of elmstuff.object.package. So the way we do that is elmstuff.object.package. Let's grab the title. Okay, so now it's telling me, well, you're not getting a selection set of list of unit anymore. You're getting a selection set of list of string. So fair enough. Update that, and here we go. Here's a bunch of package names. All right. Are there any questions on that? Does that make sense? Cool. Okay, so I think we've got time for one more exercise and then some questions and wrap up. So go ahead and open up part 3. This is where, as I talked about, we're not tied to this ugly JSON data structure that comes back. We can transform data into any beautiful Elm data structure we want. That's what part 3 is about. Usually ends at 2:50, not 3. So I'm going to just wrap up real quick, and then I will stick around for, I mean, if many of you want to stick around, we can just kind of keep talking, but I'll kind of I'll just kind of wrap up real quick and then stick around. So just to, I'm not going to go through the whole transforming selection sets exercise, but at a high level, if we look at the documentation for selection set.map, which, by the way, if you want to learn more about Elm GraphQL in general, you can just read this page, the GraphQL.SelectionSet docs page, from top to bottom, and it's actually like a pretty nice little tutorial just about how to build up selection sets. And it's nice to familiarize yourself kind of with the API of this module, because this is kind of the core concept, the core kind of module in the whole API. But so if we look at the type annotation for the map function, what it tells us is it's taking in a function which maps from A to B, and it takes in a selection set of type A, and it gives us a selection set of type B, right? So it just kind of wraps this little thing, right? So we could take, it could be anything. We could take a string like here, query.hello if it's just giving us back a string. We can do query.map, and we can pass in this little function that is string to string and upcases the string. But we can also use this as sort of like a core building block for transforming our data structures, right? So, so you'll kind of see, you know, as you play around with it, you could, you know, we could take our all packages selection, and we could just kind of do selection set.map list.length, and that's going to give us back an int that just counts up the number of packages. I think I've got a little bug in the server. So this is like kind of a core building block. So this is kind of like an abridged version of the workshop, since it's a lot of material to cover in an hour and 50 minutes. You're welcome to continue going through the exercises. It kind of walks you through the steps of eventually mapping into a record, which is just kind of this core sort of composite data structure in Elm. And as you build things up into a record, you can suddenly start building up these queries with complex bits of data. You can query for a person, and you can get that person's friend and build those up into these nested records. And those are really the core building blocks. So, we've only scratched the surface in a sense, but in another sense, understanding these fundamentals gives you the tools to figure out all the rest, because you understand the building blocks. So I hope this was useful for you, and thank you so much for attending, and I'll stick around for questions.